Awesome. Peyton's wearing my favorite shirt. I love it. Awesome, awesome. All right. I bet you have no idea what we're going to be talking about today. Got a guess? Maybe? Zach, what do you think? Zachary?
Snakes. Slithering snakes.
Oh, very
I would
good.
think of a snake somewhere in this book. Wait a minute.
What do you think, Jacob?
I think
Picture of a snake. Snake.
Yeah.
I'm thinking snake and also lizards.
And possibly lizards.
Mm-hmm.
You are right. Very good. Who's Jurgana? iPad. Might be someone. I'm always trying to figure out names of people's. Yeah, if your name's different, make sure you put your correct name in. There it is. Okay, awesome. So this week, it's the order Squamata and Rhynchocephalia. In other words, we're going to hit on some of the creepy crawlers, the ones that creep along the ground, right? Fun times. Okay, we have a lot to cover, so we're just going to dive right in. But let's start with prayer. So if anybody has any prayer requests, banana, that's too funny. Oh, Beth, I didn't even see your question. Aren't those mammals? Mammals are definitely not reptiles. We are switching gears. You are so right. Because we've been talking about mammals, like pretty much everything that we've done, right? Now we're going to switch to a different order. Yay. All right. Any? Yes. We can give thanks for the amazing snakes. All right. Well, let's go ahead and pray, and then we'll jump right in to review. All right, Father, thank you for this class. Thank you for our time together. Lord, we give you honor and praise for the way that you created these animals, all the cool mammals that we've learned so far. And now as we learn about some of these other creatures that creep along the ground and how reptiles were made according to your amazing design and just the way that you decided that they should be formed. And we just are giving you honor and praise even before we get to dive in. We ask that you would be with us, be with all the students that aren't here yet, and maybe for anyone that might not be feeling well or has family members that need prayer, we just pray that you would surround them and give them guidance and wisdom. Lord, thank you for each student here. Help us to have a great class. In Jesus' name, amen. Peyton, you're having a birthday. That's awesome. Congratulations. 12 is a big one. Happy, happy birthday. This accounts for the birthday balloon. Happy birthday to you. Happy birthday to you. A little early. Happy birthday, dear Peyton. Happy birthday to you. Awesome, awesome, awesome. That's so cool, you guys. I love it. Very fun. Birthdays are very fun. Okay, do you remember what makes ungulates unique from other mammals? It's raining birthday cakes. Allie, you're so young. Too funny. Their hooves. Good job, you guys. Or their toes. Christian, I love that you pointed that out. Their toes. Exactly. That makes them very different, right? They have hooves, but they also have very unique toes. Very fun. Okay, what is the process of digestion in these animals called? Two numbers. Ruminants. Good. They are ruminants. So they go through a process of rumination. Very good. That's how they digest, with all the stomachs. Fun times, right? Okay, what are the two main groups of camels? Anybody know? Bet that's a good point. They chew cud. Exactly. Okay, Bactrian and dromedary. Good job. Very good. The Bactrian has 2 humps and the dromedary has 1 hump. How many of you guys have ever seen a real live camel? Hi, Violet. I'm glad you're here. I saw a camel like when I was in 6th grade, and it did spit on me. But I've never got to ride a camel. I want to go to Egypt and ride on a camel. That would be fun. That's so cool. Okay, what's the most feared animal in Africa or in Mama Bear's house? There it is. Yes, you guys, the hippo. You are so right. The hippopotamus. It is the most feared animal for me. I don't know why. Oh, yes, Siberian tigers do live in eastern Russia. Yeah. They're a little scary, aren't they? Yeah. Crazy stuff. Okay. So, let's dive in to herpetology. Herpetology. We're going to look at what that actually means in a minute. Herpetology, studying these creeping, crawling animals. Oh, that's funny, Greta. I thought that was just a fun piece of information. Okay, for classification, this is where we have a big change because we're now not on the mammal track, right? The last group of animals that we will study that was created on the 6th day are those that creep along the ground. So we've already done the wild animals, we've done the livestock. Now we're headed to the end of the semester, you guys. Kind of bizarre to think about, but this is where we learn about the creep along the ground ones. So the word reptilia comes from the Latin word that means to creep. So I find it very interesting that God specifically said, let those who creep along the ground, right? Like he made them on the 6th day and he used that word creep. Not as in like, a weird person that's a creep. He's talking about things that creep along the ground, as in they're on the ground and that's how they creep around. Reptilia means to creep. So very interesting. Beth, that's too funny. She said her grandma rode a camel and fell off. That would be scary to me because they are very tall. From Monsters Inc. Yes, they like to creep very much. So yeah, it kind of looks like that guy right there. Think about these guys all creep along the ground. Specifically, reptiles would be this group right here. In herpetology, that would also include amphibians, and we'll get to them. But that's what herpetology is, amphibians and reptiles, which neither of those are mammals, right? Both of those lay eggs. They have very different orders that they belong in. But these creatures, the reptilia, means to creep. Amphibians creep along the ground too, but they are different than reptiles. And we'll get to that. All right, when we break down the classification, here's where we go, okay? Remember, so far, we've had Animalia is the kingdom. The phylum's Chordata, they have a backbone. So these guys all still have a backbone, but instead of them being mammals in that class, they are in the Reptilia class. And then they are broken into several different orders. Squamata is one of them. Testudines is another one. Crocodilia, which you probably have no idea what group that would be. And the Rhynchocephalia. Those are all the different orders that we're going to look at. That will be the classification. Yeah, I think you guys have an idea. All right, make sure you get those really big, strange words written down. I'm going to pop those in the chat just in case you're still working on that. Wow, it ended up being very big. There you go. Squamata, Testudines, Crocodilia, and Rhynchocephalia. All right, let's begin with the first two, which is the Squamata and the Rhynchocephalia. So Squamata is what we're going to spend most of our time on today. Lizards and snakes Lots of them, lots of different lizards and snakes, and all the different breakdown of what breeds and different species there are of those. Squama, if you look at the word squamata, there's this word squama in there, and that means scale. What does that tell you about these creatures? That they're long, possibly. Not the scale as in like a measuring scale. Good, Jacob. Yes, they actually all have scales. That's part of their skin. Their skin is made up of scales. So all lizards and snakes are going to belong to that group. The Rhynchocephalia group are the tuataras. A tuatara is a very unique critter, and we're going to study a little bit about him, but he's in his own grouping, and we'll see why later on. I know it sounds a little bit like a rhino, right? It's Rhynchocephalia, and you'll see why. We'll break that down later on. Okay, let's start with the anatomy, which is fascinating. How many of you guys like this little lizard dude back here? I remember when, was it Tangled? Is that the movie that has the lizard in it? When my daughter was little, I asked her like what kind of birthday cake she wanted. She wanted, what was his name, you guys? Isn't it a French name? Can't remember. You guys would know. Anyway, she wanted him for Pascal. There it is. She wanted him for her birthday cake. So I made this Pascal lizard birthday cake. No joke. It was really cute. All right. Reptiles. Some of the most interesting features about these guys, I think they keep us fascinated with God's design. And that's because of all the unique ways that he made them. He made them to do so many unique things that it's fascinating. It just keeps your attention and you almost can't find the end of studying them. So reptiles are ectothermic. Ectothermic. That means they are cold-blooded. You may or may not have this word on a quiz or exam where it says reptiles is true or false. Reptiles are ectothermic or hot-blooded animals, warm-blooded animals. That would be false. They're not warm-blooded at all, but they are ectothermic, meaning cold-blooded. What does cold-blooded mean? Anybody want to get on mic and tell us? What do you think cold-blooded is? Jacob?
Cold-blooded means they don't run themselves automatically. Their body doesn't do it. They have to get somewhere warm to get warm.
So basically, their blood's not hot. It means that their body does not regulate a temperature for them. Your body regulates a temperature, right? What's your temperature, Jacob? You know?
Last time I checked, it was 98.
98.6 is the typical human's temperature, right? Regulate that temperature. Now, what's the temperature in your room right now that you're sitting in? Do you know?
No, this is my school class. This is my schoolroom.
Okay, probably like 71 degrees,
Yeah.
maybe.
I'm not usually at home when I do this.
Which is perfectly fine. So if it's like 70 degrees in your room and you're 98.6, something had to heat you up to stay that temperature, right? It's your body. Your body has this regulator inside of it that keeps your body that right temperature. These guys, whatever temperature the room is, that's what their temperature is. So if you have a snake or a lizard for a pet, whatever the temperature is in the house, if it's 70 degrees, so is that reptile. So it will adjust to whatever the outside temperature is. And that's a very interesting thing about these animals. So they are ectothermic, meaning that they're cold-blooded. All right. Another cool thing is that they shed their skin. How many of you guys have ever seen a snake's skin? Ever get to see a snake? It's kind of weird looking. It's almost like papery, rubberish, kind of hard to describe, but it's very unique, right? So these guys, they molt in order to grow. So they outgrow their old skin. It's like basically saying, yeah, those clothes don't fit me anymore. I need to get rid of those and get some new ones. And that's exactly what happens. They get rid of them. Okay, they all have scales that make up their skin. And that basically their skin is what is shed 2 to 5 times a year. And that's what we call molting. They get rid of their skin 2 to 5 times a year. Joel, you might have to let your snake be our mascot for today. Do you have access to show him at some point, or her, depending on what it is? Okay, that would be amazing. That snake. When their skin gets kind of old and they're outgrowing it, they scratch it off by rubbing on rocks and different other rough things. They kind of rub, just like you would scratch your back against something rough. That's what they do. They scratch against something rough and it reveals the fresh new skin that's underneath. And the scales on the underside of the snake are called scoots. Isn't that the funniest thing ever? An animal that has to scoot along the ground, S-C-O-O-T, has these special scales called scoots, S-C-U-T-E-S. I just think that's funny. Oh, Violet, that's amazing. Yeah, if anybody's got pet lizards, pet snakes, any kind of reptile today, this is Bring Your Reptile to Class Day. Allie, I get that. All right, are also included in the molting process. Can you imagine that you shed your eyelid? You can even see these circles on this right here. You can see those are the eyes. The eyelids are completely peeled off. Isn't that crazy? They're basically a transparent layer that keeps the eye protected. So they kind of have this skin that forms over their eye. It does protect them so that they are not like getting sand, if they're in the desert, they're not getting sand blown into their eyes, it's this protection over them. And that means they don't have to blink. Violet, go ahead.
When my bearded dragon started shedding on her head, her eyes got giant and I was worried. And then I read and it said that they do that when they're starting to shed on their head.
That's a really good point. It probably starts to peel away and looks really big. That's my guess. That's pretty wild. Oh, that'd be fun to watch. I know it does look a little bit gross, but it's pretty fascinating. Okay, check out this guy's tongue. What do you notice about his tongue? What shape is that tongue? Yeah, it's split. This is actually not just to make it a weird looking creature. It's for a really important purpose. Their tongues have the ability to taste and smell. So when I think about a tongue for this guy right here, he's got this tongue. I'm just going to draw this. He's got a tongue that splits out, right? So a snake's tongue is actually going to be picking up particles from the air. When it flicks its tongue out, it's like, what's going to be for dinner? That's how he knows what's going to be for dinner. So the cool thing about the tongue being split like this is that, I use a different color, is that the particles he's picking up have more surface area now because it goes around this side of the split, in between the split, on the other side of the split, and now it's got a lot more surface area than if it was just going around, a single tongue that stuck out. Does that make sense? So it's kind of cool how God designed him to have more ability to pick up information so that he knows what for dinner. This also, when he picks up these particles of whatever's in the air, it sends a message to this organ called the Jacobson's organ. And in that Jacobson's organ, it processes the information. Jacob's like, yeah, that's me. And that's a pretty fascinating thing about these guys because they don't have the same kind of smell receptors. We look at a snake and we think about like their nostrils. We think about, well, don't they have nostrils like we do? They do have nostrils. Their nostrils are for breathing. They breathe air. They have lungs, but their tongue is what smells. So instead of picking up the particles in their nose like we do, they pick up the particles in their tongue, and that's going to tell them what's for dinner. So say they're excuse me, say they're like over in a bush somewhere, they stick their tongue out and they're like, oh, there's a rabbit nearby. They know where the rabbit is, where they can go find whatever their dinner is. Isn't that cool? Okay. Are you listening? What can hear but doesn't have ears? It's a snake. Go. Snakes, they do not have ears. Ah, the snake's lungs are in their little rib cage. Isn't that interesting? All reptiles have lungs, which makes them different from amphibians, because amphibians don't start with lungs. They end up with lungs, but they don't start with lungs. Snakes, they do not have ears. At least they don't have like an outer and a middle ear like you do. What they have is just a bone that does this connecting job to their inner ear and their jaw, and that picks up on vibrations. So yeah, it's very much like what the inner ear is that we have on the inside, that the bone actually moves and the vibrations tell your brain a certain piece of information. These guys don't pick up on an auditory sound wave. They pick up on a vibration wave. That makes sense. So they can hear, the vibrations like a predator that's moving along the ground. And they can pick up on, they have a high ability to pick up on those things. So they can hear by way of the vibrations, they can hear what animal's close by. So maybe they're hearing hopping, they'll know that that's a rabbit, right? Or if they hear scurrying, they feel those vibrations, it's going to be more like a mouse or something like that. That's going to give them information. I also want you to notice something. We'll talk about this later, but look at the shape of their teeth in this picture. Just let you kind of think about that one for a hot minute. Scary. If something goes in that mouth, it's not coming back out. Just saying. All right, we'll get there. Let's look at their bones. Look at this. Snakes have this amazing backbone. Now, what does the backbone encase? And Allie, you're right. That's exactly it. The teeth were going inward. They're pointed inward. Anybody know? What is this? What is this backbone encase? Very good, Greta. The chordata, very good. Or the spinal cord, right? So that protects the spinal cord that goes down their back. They don't have limbs. They don't have arms and legs. Their whole entire body is a backbone. It does look like a caterpillar, but a caterpillar, don't forget, caterpillars do not have a backbone. They only have an exoskeleton. So snakes, this is what makes snakes different than worms and caterpillars and insects. How many bones? I'm assuming it depends on the age and the breed of snake too. Because some snakes are just going to be much longer. The longer the snake is, the more bones it's going to have. Right? But you can see, isn't that crazy? It's just like this giant rib cage that keeps on going. But look at the intricacies of how that fits together. If you think about a snake's movement, they have a backbone, you have a backbone, right? Can you twist your back like that? No, I mean, if you can, we have concerns, right? Like try to twist your back. Like I can't twist it in an S shape. I mean, you can try to twist your back different ways. It's a little bit weird to think about being able to do what that back does. Their backbone, that long backbone of their body, makes it, those little teeny tiny bones all stacked together, make it so that they can have this slinky type of action that happens with their movement. We'll learn about their different slithers in a minute. Crazy. Contortionist, maybe. Yes, you're right. Another unique feature about these guys are snakes are able to eat things larger than themselves. Now, there's this really weird thing that some people talk about how snakes will dislocate their jaw. I think there might be maybe a species that does that, but that's not true for most of them. Most of these guys have this interesting little thing called a ligament that's across the front of their jaw. And this is what makes them a reptile and very different from even dinosaurs, which we'll get there when we talk about dinosaurs. These reptiles have this opening. Like if you imagine, kind of take your hand and make a Y like this. This is your jaw, okay? You imagine your jaw right here, and then your fingertips are connected with something kind of like a rubber band. So if you think about it, pretend there's a rubber band on your pinkies. Stretch that rubber band out. That's your ligament, and look at how wide you can make your mouth. If that's your jaw, you can stretch that jaw really wide, right? It's a very stretchy ligament, and they have that in place so that they can eat whatever can fit in that space, however far, right, Zachary? However far they can stretch that ligament, that's how big the animal can fit, right? So some snakes have actually been known to eat deer and even cows. Kind of crazy. The problem is that sometimes they are eating things that their body is not even able to digest, and they will swallow more than they can handle. Have you ever heard that before? Have your parents ever said that? You're biting off more than you can chew. Or you're eating more than you can handle. Snakes do that. Occasionally they'll eat too big of a bite, and then too big of a creature, basically, and then they can't digest it. Let's see, for what does this protection provide? Let's see. Oh, is there a blank? Chordata or spinal cord would be your answer. Forgot that was a blank on your notes. So spinal cord is your answer. Protects that big spinal cord. Now notice, look at this guy's his skeleton, his jaw there. You notice how the front of his bottom jaw is open because the ligament is not there, because the ligament's obviously not a bone either. Crazy stuff. All right, let's look at more about their teeth. A little bit scary. You guys will be fine. I'll be fine. Don't really like snakes for this reason. They have deadly sharp teeth, and they're basically as sharp as a needle for the purpose of injecting, just like a needle does. Like if the doctor needs to give you a shot of medicine, he's going to use a sharp needle, like a syringe. He's going to push that medicine into your body. Well, this is exactly what those fangs do. They are sharp. They insert into the skin, and then they can inject their venom into the prey. So crazy. Now, this goes back to that diagram I was telling you about. The teeth are rear facing, so the prey cannot wiggle free. Crazy stuff. So if all the teeth are basically like you've got this creature here, some of them only have two big fangs in the front. Some of them have teeth that are all rear facing like this. That means that whatever comes into their mouth is only going to be able to go one direction. It cannot go backwards. It can't pull backward because those teeth have locked it into place. And so they just keep getting more momentum around their prey, and it goes deeper, deeper, deeper inside of them. Isn't that creepy? Because they creep along the ground, right? Okay. Okay, let's look at some of the behavior. Like a granny mouth. It looks cool. It looks crazy. Okay, let's look at the different groupings of snakes. First of all, we have constrictors, and then we have venomous, and then we have colubrids. Now, I'm going to ask Joel, if you don't mind unmuting, tell us what kind of snake you
have. He's a black rat snake.
Black rat snake. So which category would he be? A venomous snake?
No.
Obviously not, because I mean, unless you devenomized him, you wouldn't have him in your house. Is he considered a constrictor?
I don't think so, no.
Yeah, you're right. He's actually a colubrid. Rat snakes are colubrid snakes. And colubrid snakes are our friends. I mean, they can still bite, but they're not going to be venomous. Have you ever been bit by it?
No.
Because he's probably just pretty chill. They like to eat mice, and obviously his name's Rat, right? Rat snake, so he probably likes to eat rats.
Mhm.
Yeah. So Greta, it's actually garter snake, garter with a T, a garter snake, which is actually a very big friend to people too, because they are taking care of mice and kind of obnoxious creatures like that, and they will keep that population down. And they're not going to hurt you, right? They're not constrictors or venomous. So whenever you get the chance, if it works for you to get your snake and to show us, I would love it. Whenever if you want to over break, that's fine too. So whatever works, that would be awesome. Yvonne.
Garter snakes are actually venomous, but it's only at the very back of their teeth. So they need to bite in and hold on for a very long time for the venom to actually go. But it's not good enough to kill. It just will make your hand numb for weeks.
Interesting. I had never heard of that before. That's awesome, Yvonne. Yvonne's got amazing plethora of all kinds of random facts, and that's so cool. That's neat. So the venom is only in the back, but they are still considered colubrid. They fit in that category. I love the eyes. That's too funny. That's awesome. There are several different snakes that are considered the most dangerous. The pit viper is one of them. We're going to get to that too. But let's look at each of these groupings. The constrictor, this is crazy. This guy died trying to eat this animal. And so they actually kept it in a museum so that you can see this is what they do. So constrictors, their job is to suffocate the animal, right? They want to stop the blood flow of their prey. And they do that by wrapping tightly around them, and then they just squeeze until they can't breathe. So they suffocate them by keeping them from breathing. The most common ones are going to be the giant anaconda and pythons. Yeah, it's a squeeze hug that doesn't stop when it should. And here's the point for all of these guys. Snakes are like this all across the board for the most part. They don't want to fight, which is interesting to think about. They even the ones that will bite, they don't want to fight with their meal. So what they do is they try to kill their meal, then they want to eat in peace. That's the point. So that's what constrictors do, is they will suffocate their prey, then they'll eat them. But again, they like to open their mouth really big and they'll eat whatever they can. But if they eat something bigger than they can actually digest, they might die in the process too. Yeah, death hug, that's right. Yes, boa constrictors, same thing. Now, some people keep boa constrictors as pets. My daughter was saying the other night that she would like to have a pet snake, and I'm like, just no constrictors. Because if they do get loose, they have known to actually kill their owners, because they're just doing their natural instinct of squeezing their prey, right? And that's just not good. So you want to make sure that your constrictors are either in a very well contained cage, or or don't have them. Yeah, I don't know the population of boa constrictors. They're actually humongous. Some of them are enormous. Giant anacondas are huge. And they can feed whole villages. If they catch one and they cook them, they can feed a whole village. It's that's how huge they are. Venomous snakes, on the other hand, are the most feared because their venom is very deadly. Some of them have the ability to instantly kill a person. Now, the venom is a couple different directions it can go. It could be one that paralyzes the victim, and what happens is it goes into the nervous system and it releases these neurotoxins that shut down the person's nervous system, and it makes them paralyzed. Then the snake can eat in peace, which is part of his point. Or other types of venomous snakes will use hemotoxins, which means it's going to interfere with their blood flow. And so that's more in the circulatory system, where it shuts down the flow of their blood. and it makes it so that they can't move that way because their blood is not flowing. They basically die. So it can go either direction, where it attacks the nervous system or it attacks the circulatory system. Either way, the venom has this ability to kill a person or an animal, or at least slow them down long enough that they can be eaten. Now, I want you to notice something. With venomous snakes, they always have a certain shape to their head, right? This is how you tell the difference between a venomous snake and either a constrictor or even a colubrid snake. Venomous snakes have this V shape, most of them. I think there might be one that's a little bit harder to tell. Most of them have this V-shaped head, and you can see why. They have these venom glands in the corners of their head, so it makes it that triangular shape, right? Yeah, it's because of the venom glands. So if you see a snake with that shape of their head, it's a good indicator that you want to stay away. Go ahead, Yvonne.
I think it was the coral snake. It doesn't look like that, but it is very venomous.
Yes, coral snakes are extremely dangerous. And there's a certain saying, I'm trying to remember. Maybe if somebody knows the saying, you can tell us about it, but we'll get to coral snake in a second. Jacob, go ahead.
So, what does a coral snake look like?
Actually, I have one on the next slide.
Oh,
and
okay.
I think I can remember. I think I remember the little saying, and I'll tell you in a minute. So snakes generally, of course, don't like to struggle with their meal, just like I was saying, but they will inject the venom or squeeze them, depending on what kind of snake it is, to make it easier for them to eat in peace, which is crazy. Oh my goodness, Zachary, that's so crazy. Try to eat the snake or eat the eggs in your yard, probably chicken eggs. They'll take care of the chicken eggs, and that's their meal. They enjoy that. Here's a good picture of some of these venomous snakes. This is the coral snake, and just like what Yvonne was saying, their head isn't quite as triangular shaped. And I think the saying goes, is it yellow on black, red on black, friend of Jack? Yellow on red, the person is dead, or something like that. But there are different types of snakes. I have to look at the little saying now that I can't remember it exactly. But it's basically, if you have the idea to identify these guys, yeah, kills a fellow, yellow. Yep, that is it. So look at that little saying. Coral snake saying. It's basically for helping you identify them, because there are other snakes with these stripes, and you might think that it's a coral snake when it's not. Red on yellow, kill a fellow, red on black, venom lack. That's another one. I've heard friend of Jack. That's another one. Yeah. Yeah, there's all these different sayings. The biggest thing is, let me show you the picture here. If I can find it. It's I think it's the king snake, scarlet king snake. Here's the difference between the two, and you can see why people would be confused if you look at it. Red touch yellow is a coral snake, but the red touching black, it's the scarlet king snake, and it's completely harmless. This is important to know because just what Yvonne was saying, that you can't tell by their head. So that's why it's important to know the difference. To see how similar, they do look pretty similar. Yeah, cobras are definitely venomous. So let's go back and look at those different venomous snakes. Here's some common ones. Of course, the rattlesnake, it's a common one. The cobra. Cobras have this unique thing where they like stand up. It looks like they're standing up, and they'll put their head up and they flare these skin flaps open to make themselves look bigger. And that's when they feel threatened, they'll pull those out to make themselves feel like they're bigger. 3 is a coral snake, which is very deadly, highly deadly. 4 is a cottonmouth. Cottonmouths are very deadly as well. and then 5 copperheads. So any of these snakes are going to be very dangerous. They're deadly. Okay. Yeah, king snake is trying to trick. It's got its little Halloween costume trying to trick everybody to what it is. Oh no, Beth, that's crazy that it's snowing so much for you. That is crazy. Okay, colubrid snakes are the most common, and this is over 2/3 of all the snake species. They are colubrid. When we say colubrid, they're non-venomous. And here's another picture that helps us kind of see. The only exception there, of course, is the coral snake. But these non-venomous snakes are all over the world. They keep the rodent population down, which is very nice. This is kind of like what Joel was showing. You can have them as pets even. So bull snakes, garter snakes, and rat snakes are all different common colubrid snakes. All right. I think I should go on break. You guys got some great sayings. You could make up your own too. I know, Allie. I'm not a big snake lover, but I don't mind colubrids. They're pretty cool. All right, let's go on break. When we come back, and if Joel, if you want to get your snake and show us, that'd be awesome. Or if you want to do it at the end of class, either way is fine. And then when we get back, we'll dive in a little deeper, and we're going to see how they actually move, what the patterns of slithering are, which is kind of fun. All right, we'll be back in a few minutes. Kind of laid out on the snake. Of course, the venom gland's down underneath in the skin. They're just sort of making it transparent for the diagram. The heat sensing pit is up here. The nostril is close by. So the heat sensing pit is not a, it's not a nostril, but it's real close to them. A lot of people would probably think of them as a nostril, but it's basically their ability to pick up on the temperature. They have, of course, their venom duct that's attached to the venom gland, and they have fang down here, the fangs that are hollow, and they're retractable, meaning they can come back up into their head, which is helpful to them. And they have a sheath right here that fang can fit in so that it can go back up in, it can be retractable. The recurved teeth aid in eating the prey. It's going to keep it shaped so that it keeps going one direction. They have the chemical sensitive forked tongue, like we showed earlier. And then they have this extendable glottis that allows for breathing while they're ingesting their prey. If you've ever wondered about that, like their mouth is so full, how are they breathing? They've got this extra ability right here that gives them space to breathe while they're eating. Kind of crazy. Jacob, go ahead.
I think that the prey would cover the glottis.
The glottis is probably able to expand when they need it and close when they don't. That's the actual nature of a glottis anyway. You actually have an epiglottis. Those things, it's like a cap that opens and closes, a little bit like a door. So it's a little bit like that.
Okay.
All right, here's a cool thing. You guys can pop in your notes. These are and I'll get to the matching part of this in just a minute. You might be able to just to see it yourself, but there's a little matching area on your notes. Oh, Beth, that's too funny. So they move in one of 4 different ways, and sometimes the same snake can move in those ways. It's just depending on what they want to do. Concertina motion is an accordion type action. Lateral undulation is serpentine. 3 is sidewinding. And 4 is rectilinear motion, like caterpillar. So we're going to look at what those all mean, kind of break those down. But these, I wanted to show you the action. I know, look at that guy. That's sidewinding. Isn't that cool? The sidewinding, I think, is pretty fantastic to watch it move like that. Because they don't have legs, right? So they don't just easily get around however they want. So concertina motion is when the snake pulls its body up into folds and then straightens out by pushing against the back scutes that are on the underside to move forward. So you can see it's like scrunch and then spread, scrunch and spread. That's the concertina motion. So you can match that up. I think it's the second one down. All right, next is lateral undulation, which is also known as the serpentine motion. The snake moves like in this S shape. This is pretty much what people think about with snakes. They go in this S shape, pushes its muscles against rocks in the ground, and it goes in that S shape. And that would be the bottom one on the right side. You can match that one. The next one is sidewinding, which is my favorite because it's really weird. It lifts its head off the ground and pushes in a direction it wants to go, almost in this like circular, curvy, I want to say like a coil motion. Isn't that cool? And then it can, I don't know how they can draw that to explain what it does. I think the little animation helps with that. And then the last one is the rectilinear or like a caterpillar type motion. And you can see where it like raises its body up a little bit and the scutes will grip on the ground and then push it forward so that it's got forward motion. And that is the top one. Snake scutes, grip the ground and push it forward in a straight line. Ah, okay. I think here it is. Concertina motions, second one. Lateral undulations, the bottom one. Sidewindings, the third one across. Rectilinear motions, the first, the top. Very cool. Awesome. Everybody got that? Cool. Okay, here we go. Let's look now at some more of the lizards. These are more creepy crawlers. We're going to focus on the lizards. Little or large, little or large lizards. That's hard to say actually, really fast. The smallest known lizards are the dwarf gecko and the nano chameleon. I think this is the dwarf gecko and this is the nano chameleon. And they're found in the Dominican Republic and in Madagascar. Can you imagine having a little lizard sit on the top of your finger like that? It's so teeny weeny. They're very, very tiny. The largest, anybody know what the largest one is? What's the largest lizard? Everybody look up on Google really quick, right? I know those are so cute. The monitor lizard, specifically the Komodo dragon. Monitor lizards are in Africa, Asia, Papua New Guinea, and Australia. But the biggest is the Komodo dragon that can be about 9 feet long. I think I've even heard of them bigger than that. And they've been known to eat large animals like cows and deer and other Komodo dragons. They don't care. They just will eat whatever they can get their mouth on. Part of what they like to eat is rotten meat. So if there's any animals that are dead and have already started decaying and rotting, that's their favorite meal. Isn't that disgusting? That's what monitor lizards is, specifically these Komodo dragons. If you ever take my pre-biology class, we do all these dissections and different things, but we have a whole section where we see a video on how Komodo dragons eat. Very interesting. Okay, let's look at some more. Look at the eye on the lizard. They have this nictitating eye. Lizards are 4-legged reptiles with 5 digits on each foot. like toes, right? Fingers. They have ear holes for hearing. Most of them have a nictitating eye. Some of them might be a little more like the snake, kind of like what Violet was saying, where they can peel off. The nictitating eye is protective for them. Some of them actually have a third eyeball on the top of their head called a parietal eye. Isn't that interesting? And that eye doesn't necessarily see. It just has a feature about it that can pick up on visual information the same as their eyeballs do. But the third eye gives them a little bit more ability to have taken in sensory information. No, it's not a crocodile. This is a lizard. Crocs are in their own grouping. Remember, these guys have a backbone, right? So he's got a skull up here. He's got a backbone that goes down his back, down his tail. But say he loses his tail, that backbone and the cord that was encased in that backbone is now missing. So what grows for the regenerated tail, what grows does not have the same thing. It does not have a spinal cord. It has basically a piece of skin that grows in its place. It might have a little bit of ability to move, but it's not going to be the same as the original tail. The regenerated tail is just a mock-up to kind of make it not look weird. So it has a tail, but it doesn't have the features of the original tail. Does that make sense? Isn't that crazy? So you can even tell, if you found a lizard, you can tell if it lost its tail already. You can just inspect its tail and kind of look at it to see if it looks like a regrowth or if it is the original. Very fun. So here's the different things you can label on your diagram. The eye and the parietal eye are on the top. Then we've got the soft spine. Some of them have a spike on that. Some of them just have a ridge, but that's their soft spine. They have ear holes on the side for picking up sound information. Subtympanic scale, that's going to be a part of their picking up on vibrations. If you think about the word timpani, that tells you, it's a little tip on that one. The dewlap, some of them have them, some of them do not, but some, like an iguana does, but some lizards would not have the dewlap. The dewlap is like this flap of skin that they can actually push outward to make them look bigger. Remember, that's what they do when they want to be more dangerous or look scarier to their predators. They will, put out their skin, make themselves puff up. They do have foot digits and they have claws, and then their regenerating tail. All right. So I think that was labeled on the last page, even though we went on to the last page of your notes. Hopefully you guys all got this. On the final page of your notes, on page 6, it's basically this little video that we saw.
Okay, you're on camera. What happened? What'd you get?
They can regrow their tail. Okay, so let's skip down to where it says gecko feet. How's it going, Joel? Is he cooperating? Is it cool? Like, if you want, you can let us know if you want to show them to us.
I think I need a little longer.
Okay. Too much fun. So a gecko is a very interesting kind of lizard. They have the ability to walk on walls or on glass, and they do that. They don't have suction cups on their feet. They do that with something called setae. And setae or setae, depends on how you want to pronounce it, either way. The setae is basically all these teeny tiny little hairs that kind of stick together and they act like grippers. So it's almost a little bit like how a like Velcro almost, but it can stick on walls. And that's the same exact thing that happens for like spiders. They have this settee that sits on the bottom of their feet, and that's how they can walk on the walls. Pretty interesting to think about. Okay, Beth. Yvonne, go ahead.
Humans have actually made a kind of material like a settee, which, like, if you can put an apple onto it, and then when you face it downwards, the apple won't fall off, but when you face it upwards, the apple will just fall off because the settee aren't sticking onto the apple.
That sounds like a fun experiment, actually. That would be cool to try. If you think about it, and you can also like make it look like it's a magic trick when really it's just science. That's awesome. Okay, let's look at the last one is the tuatara. And this guy is very interesting. He looks like a lizard, but he has to fit in his own category because they have a couple differences. They are, he's in his own order, the Rhynchocephalia. And in this group, the tuatara does not have ear holes like a lizard. And the other really interesting fact about these guys is they actually do well in the cold weather. So one thing that I wanted to mention about being cold-blooded or ectothermic means they adjust, of course, to the outward temperature, right? So, like for instance, if I have you know, a turtle in my pond, which we do, we have turtles in our pond. In the winter time, it gets very cold. And so they will get down to a place where they are adjusting to the temperature outside, which could be 25 degrees. It's just really, really cold, right? So if their body adjusts to that temperature, what happens to their molecules is they slow down. Here's like a tiny little physics lesson for you guys. Molecules are just like these little dots. I'm going to see if I can make dots. All right, here's your molecules. And this is true for most, well, all cold-blooded animals too. Here's the molecules. What happens when it's warm is these molecules will be more active. And you can see this in like basically when you're, like if you boil water, when the water's boiling, it's moving, right? In fact, it actually can bounce around in steam because that's how, when it's hotter, it's going to be moving a lot faster. So all these are bumping, moving, banging, back and forth, jumping. They're very, very active, moving, 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 right? And all these little dots are all over the place moving in the heat. Now, when it's cold, what happens is everything slows way down. What happens in an ice cube to the molecules? What are they doing? They're not moving. They're frozen, right? They're just like, they're technically, I think they are moving a tiny bit, but they're frozen. They aren't going to move. So the same is true for this tuatara or any other cold-blooded animal. Their molecules are going to slow down. So what happens is that turtle that's out in my pond isn't going to move. It's not going to move. It's going to look like it's dead because it's not moving. But when it warms up, then all his molecules are going to start jumping around all over again, right? His molecules are going to be like, hey, we're warmed up. We can actually move. So any of these creatures that are cold-blooded, they count on their molecules warming up for them to move around. The interesting thing about tuataras is they can handle cold weather more than most reptiles. And so more than most lizards. They actually like the colder weather. So that makes them that's a unique feature to these tuataras. Another interesting thing about these guys is not that they live in New Zealand, which is kind of cool, but that they have been known as living fossils because these bones of a tuatara were found sitting right alongside dinosaur bones. The dinosaur fossils and the tuatara fossils were right beside each other, but tuataras haven't changed. So the supposed millions of years between these species doesn't exist. They were both captured probably in the flood together. Interesting, huh? So that confirms that there's we call that a creation confirmation, or the flood is helpful to help us understand some of these creatures and which ones were existing when. So dinosaurs were not necessarily millions of years ago. I know that's not popular among scientists, but it's actually very easy to track because of the flood. Okay, let's look at, if we got some time, if it works for Joel, you can, at the end, you can show us your snake. All right, for habitat, these are all the different places that we're going to be looking, especially if you're doing your map. Southeast Asia, which is over here, southeast, down in these areas, Southeast China, closer to India, there's going to be king cobras, freaky a little bit. Oh, that's cool. Weather determines the gender on turtle babies. I did not know that. That sounds pretty crazy. Africa and Madagascar. Here's Africa. Madagascar is over here. They have chameleons, like Pascal. Middle East has the leopard gecko, which would be interesting. North America has the Gila monster, the Mexican bearded lizard. I think that's supposed to say bearded lizard. Animals and geckos. Also, South America has boas and iguanas. Australia has the frilled-necked lizards and death adders, which does not sound like a friendly creature to me. And Indonesia has Komodo dragons, which those are very fun to study if you ever get a chance to look at those. Okay, one more thing. I'm going to go over our homework. Also, I highly recommend, Joel, that you make a little hat and mustache for your snake. Does that not look hysterical? Ah, there he is. Okay. All right. So for homework, you're going to read lesson 10, complete the special snake abilities in Venn diagram, and then complete the venomous snakes research project. Is about your particular state where you live, which snakes would be present there. So I'm going to stop sharing real quick, and I'm going to pin Joel's camera so we can see. There's his little head. Oh, I'm loving it. He's cooperating so well. Look at that. He's cute.